Well, dear students, uh, today I will take here the topic semiconductors. I have told you in earlier or previous videos about metals, insulator, semiconductors by and differentiated them on the basis of resistivity, conductivity, and then I told you in semiconductors energy band formation, concept of electrons, holes, etc. Today here we will take semiconductors in general, in details. So you know semiconductors are the device materials whose conductivity lies between good conductor and insulator. Now, I also told you that semiconductors are elemental and compound semiconductor, organic, inorganic in last video. But here we will restrict ourselves to elemental semiconductors. So semiconductors are the material which have conductivity lying between good conductor and insulator, and they have got one important property that on increased temperature their conductivity increases while metals decreases. Now semiconductor are two types: pure semiconductor or intrinsic semiconductors. And number two, impure semiconductor or they are called extrinsic semiconductors. Actually, to explain anything we need language, and sometimes in language we don't understand the meaning of particular word. So what are pure semiconductors? So I will take here pure semiconductor or intrinsic. So this word intrinsic confuses students too much. Pure or intrinsic semiconductor. Intrinsic means due to its formation, natural, by nature, the behavior which is by nature or formation or by birth, inherent properties are called intrinsic properties. Don't think that it is internal. No. Intrinsic property means which are possessed by the thing due to its birth, due to its formation, how it was formed, that way. So pure semiconductors. The semiconductors which show their conductivity due to their own structure. due to their own structure. For example, silicon Si and germanium are intrinsic semiconductor. Intrinsic semiconductor. The material. So these are two elements. I told you that I will be restricting myself to elemental semiconductor. Germanium and silicon are the semiconductors. Now, why do they have low conductivity and why do they conduct electricity and why conductivity increases with increase of temperature? Now you know the silicon, germanium, carbon, these are elements of 14th group of periodic table. 14th group of modern periodic table. So these elements have only 4 electrons in their outermost shell. And suppose it is silicon atom here. And it has 4, this is another silicon atom here. I take this opportunity here to explain you. These are silicon atoms. Silicon, all are silicon. Okay. Now, how do they get bonded together? Silicon is solid. And silicon, in fact, you know, is found sand is silicon dioxide. It is in large quantity in nature. Silicon. These are silicon atoms. All are silicon. Now, every atom has 4 valence electrons. So these atoms are bonded together by single covalent bond. 2 electrons together make a single covalent bond. Don't get confused that 2 lines represent double bond. We are representing the 2 electrons bounded together here to make this. So these are 2 electrons here. These are single covalent bond. The 2 lines are representing 2 electrons which makes a single covalent bond. Bond means force of attraction. I have told you the meaning of this line also. The electron has ability, freedom to oscillate along these lengths. These are the bond formation between silicon atoms. This is the structure of silicon atom, silicon element as a solid. Here also. Now I'll take here this is hollow circle. Indicate that some electron is lost. Means I have generally, deliberately sold. These are electrons here. So you see that this silicon atom bonded with 4 neighboring silicon atom with covalent bond. Here due to thermalization, some bonds are broken. Means electrons are outside the bond. This difference of electron in the bond is called hole. The number of hole or electron depends upon temperature of the material. If we increase temperature, more electrons and holes may be created. Because of thermalization, electrons start oscillating with large amplitude and it may come out of the bond. I hope you have got my points. Silicon or germanium have 4 valence electrons. Every atom gets bonded with neighboring atom of silicon or germanium itself by single covalent bonds. You can prepare the note of this, please, or take the help of book, or you make notes from my lecture by pausing the video. I hope you have got a silicon crystal. It is hexagonal crystal actually. Valencies are in different directions, these bonds. So here a hole is created. But this hole does not remain fixed here. It tries to fill up this hole. This atom tries to fill up this hole by taking electron from neighboring atom. Then hole is created here. So on. It may build up from here, then it may build up from here, and so on. So that way hole inside the structure of crystal of silicon is not at rest. It keeps on moving and it acts as positive charge carrier. Electron, actually I have told you that for conduction we need some free charge carriers. We need some free charge carrier for conduction of electricity. So the number of electron and hole exist inside crystal at some normal room temperature. At very low temperature, near 0 Kelvin, no bond will be broken, no free electron, no hole will be there. That is why semiconductors do not conduct electricity at very low temperature. I have told you while defining semiconductors, while explaining the conductivity on the basis of energy bands in solids. So at very low temperature, means near 0 Kelvin, no electron hole are created. The electron and hole are created here because of thermalization. Thermalization means the movement of atoms or electrons inside the crystal due to temperature. As we increase temperature, electrons and hole increases. I told you hole created any bond may be filled up by taking electron from neighboring atom or neighboring bond, and so this hole keep on moving inside. From thermodynamic consideration, it has been proved that number of electrons per unit volume of the conductor, semiconductor, and number of hole per unit volume are same, and we write here Ne equal to NH. What is Ne? Number of electrons per unit volume. NH, number of holes per unit volume. I have told you in metals the number of free electron is also 10 to the power 29 per meter cube, but here the number is small. It may be of the order of 10 to the power 22, 24, like that. Number of free electrons. That is why charge is small and hence they show small conductivity. On the basis of energy band diagram, I have told you that it is conduction band here, it is valence band here, At very low temperature, valence band completely occupied by electron, and this is the energy gap here, less than 3 electron volt. So some electron jump from valence band to conduction band due to thermalization. Thermalization can provide energy to electrons, which they need to go across the energy forward energy band, which is called Eg here, less than 3 electron volt. And further it can be proved here, number of charge carrier per volume of Indian semiconductor, that is called Ni. I have to rub this to do something other. So here these holes increase in valence band and electron in conduction band on increasing temperature. And it can be proved here Ne into NH. Remember, Ne is the number of electron per unit volume, NH number of hole per unit volume is equal to, we write Ni square. Ni here, Ni is called intrinsic charge carrier density. Intrinsic charge carrier density is Ni. So Ni square, this is very important relation here. Ni square equal to Ne into NH. It can be proved on the basis of thermodynamics. So I hope you have got my point. Why does the conductivity of semiconductors increase? This is a very good question here. Why does the conductivity of semiconductors increases with the increase of temperature? As we increase temperature of a semiconductor, the number of holes in valence band, number of holes in valence band, and number of electrons in conduction band increases. This was a question in one exam. Why does the conductivity of semiconductor increase with the increase of temperature? So answer is this. As we increase temperature of semiconductors, the number of holes in valence band and number of electrons in conduction band increases. And this increased number of electrons and holes, number of electrons in conduction band and number of this increased number of electron in conduction band and holes in valence band increases the conductivity of semiconductors. This is very important to know. This was about intrinsic semiconductors in this video. Remember, Ne is the number of electron filled volume and hole filled volume. And Ni here is called intrinsic charge carrier density. So please watch this video carefully, make your own note. You can take the help of book. But this is a very simple chapter, new for the students. भाई नया तो आएगा ही जब आप पढ़ते जाएंगे. Every time you will be getting more and more informations, and by revising the topics you will be able to learn nothing else. Thank you. If you like video, please like video, subscribe my channel and ask your friend and share the video, please. Thank you.